Lesson 1-2 is understand rational numbers. Rational numbers are just numbers that can be written as fractions, which we also call ratios. It's important to note that ratio is in the word rational. So when you see rational, you can think, I can write that number as a fraction. Now, you could see a rational number as an integer, or you could see it as a fraction, and you could see it as two different types of decimals. It could be a decimal that is terminating, that means it ends, or it could be a repeating decimal. For example 1, we're going to write each fraction that's given as a decimal, and then classify the decimal as either terminating or repeating. All fractions, when converted to decimals, are either terminating or repeating decimals. So, first problem, we start with the fraction 52 over 80. We could say this as 52 out of 80. And to convert from a fraction to a decimal, we could use long division. So the numerator always goes under the division sign or under the division symbol. So this is 52 divided by 80. And we think 80 will not go into 52. So I need to place a 0. And since I am going into the 10th place, I needed a decimal, and I just moved the decimal point directly above the original decimal so they're lined up. And I think, how many times will 80 go into 520? You might go to the side and do some scratch work or use a calculator to assist you here. We know it didn't go into 52 at all, but 80 will go into 520 6 times. So I multiply back. 6 times 80 is 480. Now I subtract. 520 minus 480 is 40. I'm not finished. I still have a remainder, so I'm going to extend my problem out by adding a 0. And 80 will go into 400 5 times equally. We multiply back. 5 times 80 is 400. And we get a remainder of 0. So a remainder of 0 means that it ends. So which kind of decimal would end? Terminating or repeating? Looking at a calculator, 52 divided by 80, we hit equal, and you get 0.65. Notice that it ends on the calculator screen. It doesn't go all the way across your screen. Sometimes you have problems that have lots of digits all the way across the screen, but this one doesn't. It just ends. So it's a terminating decimal. Okay, our next fraction is 5 out of 18. So we're going to use long division again. So when we divide 5 by 18, 18 will not go into 5. So I'm going to place a decimal behind those and a 0. 18 will go into 50 2 times. 2 times 18 is 36. We subtract and get a remainder of 14. I place a 0 because I still have a remainder. So now I'm going to find out how many times 18 goes into 140. And it goes in 7 times. 7 times 18 is 126. We subtract, and we get a remainder of 14 again. So right now this is looking like it's not going to end, but let me just test it and be sure. When I bring down another 0, 18 goes into 140 7 times again, with a and that 7 times 18 equals 126. So I, once again, have a remainder of 14. And as you can see, this is repeating the same pattern over and over again. So we see if the remainder is repeating, that this is going to be a repeating decimal. I do need to write my decimal. 0.2, and then that 7 just keeps on repeating. Since the 7 repeats, I only have to write it one time and place a bar over the digit that repeats. You could have a case where you have 2 or 3 or more digits that repeat. For example, you could have 0.27, 27, 27, and then you'd put the bar over both digits, 2 and 7. But since only the 7 repeats, that's the only digit that goes under the bar. And this is a repeating decimal. Looking at a calculator, 5 divided by 18, enter equal, and we get 0.2777777. And what you see is that it just keeps repeating the 7. It went all the way across the screen, so this was a repeating decimal, and you can see that on a calculator. Example 2, explain whether each of the following is a rational number. A part, -6.382. Well, remember, a rational number, if written as a decimal, is either terminating or repeating. This decimal ends. So yes, it's rational because it's a terminating decimal. Problem B, 1.5399, and then there's an 8-1 with a bar at the top. And that tells us that the digits 8-1 repeat over and over. So it's really 1.5399818181, and it'll just keep going forever. So yes, this is also a rational number because it's a repeating decimal. And then 0.43524982, and then we see a ... at the end. This ... at the end shows that this decimal just keeps on going. It will go on forever. It does not end, so it's not a terminating decimal. Also, you don't see a bar over any digits. It does not show digits that repeat in order, so it's not a repeating decimal. So no, it is not a rational number. The decimal doesn't terminate or repeat. Example 3, what is the fraction equivalent of each decimal? The first problem is 0.28. The fraction is a numerator over a denominator, where the numerator is the digits after the decimal, and then the denominator is the place value of the last digit. So the digits after the decimal would be everything from the decimal back, which is 28. And then the place value of the last digit, well, the last digit is this 8, and it's in the hundredths place. Remember, after a decimal, you go tenths, then hundredths. So it's 28 over 100. So we've got a fraction equivalent, but we do always want to reduce a fraction as far as it can be. So we'll think for just a minute, what's a number that 28 and 100 will both divide by? If you're not sure, just start by seeing if they're even. If so, they'll both divide by 2. But you may notice that these will also both divide by 4. So I'm going to divide them both by 4. And that means that this fraction reduced is 7/50. And then we have -3.8. So to find the fraction part of this, we know that we're going to take the digits after the decimal and place it over the place value of the last digit. But this problem has something in front of the decimal. So I take whatever's in front of that decimal, which is -3 in this case, and that is an integer. That is an integer that we're going to place in front of the fraction. So it's going to be -3 and some fraction. So I'm going to go ahead and work out this problem. The digits after the decimal is just an 8. That 8 is in the tenths place. I can reduce this fraction. You'll probably notice they are both even, so they divide by 2. And we get 4/5 for the fraction part of this problem. And we're finished. Okay, so I want you to try a problem. I just want you to take this decimal, 2.35, and write it in fraction form. You can look back at your notes. I'll give you just a little time to try this. Pause the video and then come back and check your answer. Okay, so you'll notice there's a number in front of the decimal. So everything in front of the decimal, you'll write in front of your fraction. Then to get the fraction part, remember you take the digits after the decimal, 35, that's your numerator, and then take the place value of the last digit. Well, that digit 5 is in the hundredths place. And then see if it could reduce. You might notice that 35 and 100 both end in 5s and 0s, which means that these numbers will both divide by 5. 35 divided by 5 is 7, and 100 divided by 5 is 20. So we have 2 and 7/20.